dear friends, welcome back to our channel Anvinay Kumar Basics of Physics. This is the right place to learn. Children, ఈరోజు ఈ వీడియోలో నేను ఫార్మేషన్ ఆఫ్ స్టేషనరీ వేవ్స్ ఇన్ ఏ క్లోజ్డ్ పైప్ అనేటువంటి లాంగ్ ఆన్సర్ మోస్ట్ ఇంపార్టెంట్ క్వశ్చన్ డిస్కస్ చేయబోతున్నాను. వీడియోని స్కిప్ చేయకుండా లాస్ట్ వరకు చూస్తే ఖచ్చితంగా కంటెంట్ మీకు అర్థమవుతుంది. ఆల్రెడీ నేను ఫార్మేషన్ ఆఫ్ స్టేషనరీ వేవ్స్ ఇన్ ఏ ఓపెన్ పైప్ అండ్ ఫార్మేషన్ ఆఫ్ స్టేషనరీ వేవ్స్ ఇన్ ఏ స్ట్రెచ్డ్ స్ట్రింగ్, ఈ రెండు వీడియోస్ కూడా ఈ రెండు లాంగ్ ఆన్సర్లు అప్లోడ్ చేశాను. ఆల్రెడీ ప్లేలిస్ట్ ఉంటుంది, మోస్ట్ ఇంపార్టెంట్ క్వశ్చన్స్ సెకండ్ ఇయర్ అని ఒక ప్లేలిస్ట్ ఉంటుంది. ఆ ప్లేలిస్ట్లో అన్ని లాంగ్ ఆన్సర్స్ కూడా అప్లోడ్ చేయడం జరిగింది, ఒకసారి చూసుకోండి. ఓకే, నౌ వితౌట్ లేట్ ఐఎమ్ కమింగ్ టు ద టాపిక్. సో డియర్ చిల్డ్రన్, how the stationary waves are formed. I already explained this one in previous video, but to understand this question very simply, I want to give a definition for that. What is a stationary wave? When two progressive waves of same amplitude and frequency, when they are superimposed together, they can constitute a stationary wave. Clear? So look here once. Definition is there. When two progressive waves of same frequency and amplitude are superimposed in opposite direction, then stationary waves are formed. In this diagram, this black color is the one wave and this one is the second wave. Clear? I am showing now here, this is the direction of black one and this is the of this one. To identify the two waves, I given different colors. Clear? When they are superimposed like this, then we are getting one stationary wave. That is the first thing you have to remember. The condition is what? Waves must be have same frequency and same amplitude. And next thing is, in a stationary wave where the maximum displacement is available, those points are called antinodes, and where we have displacement means minimum, they are called nodes. Stationary wave lo ekkadaithe amplitude ఎక్కువ ఉంటుందో ఆ పొజిషన్ మనకి మ్యాక్సిమం డిస్ప్లేస్మెంట్ అంటే ఏంటి? ఆంప్లిట్యూడే కదా. సో ఆంప్లిట్యూడ్ ఎక్కువగా ఉంటుందో వాటిని మనం యాంటీ నోడ్స్ అంటాం. మ్యాక్సిమం డిస్ప్లేస్మెంట్ ఆఫ్ వైబ్రేటింగ్ పార్టికల్ ఇస్ మోర్, దోస్ పాయింట్స్ ఆర్ కాల్డ్ యాంటీ నోడ్స్. ఇక్కడ ఏవైతే ఇలా చూపిస్తున్నానో బ్లాక్ కలర్, దీస్ ఆర్ ద నోడ్స్. దట్ ఈస్ ద ఫస్ట్ పాయింట్ యూ హ్యావ్ టు రిమెంబర్ చిల్డ్రన్. అండ్ ఆఫ్టర్ నెక్స్ట్ థింగ్ ఈస్ ద డిస్టెన్స్ బిట్వీన్ ఎనీ టూ సక్సెసివ్ antinodes is equals to lambda by 2, and a distance between a successive node and antinode is lambda by 4. So when you have idea about these two properties, you can easily explain the formation of stationary waves in a closed pipe. So now let's enter into the topic. A closed pipe, an organ pipe which has one end is open and one end is closed, that pipe is called closed pipe. And the pipe which has both ends are free or open, that should be called open pipe. That's you have to remember. So children, here we are taken, it is a organ pipe that should be having like this. It is the open end and this is the closed end. Now it is called a closed pipe. What it is called? Closed pipe. So children, how the stationary waves formed in a closed pipe? Let us discuss. Here we are taken one tuning fork and that should be excited and kept over the open end like this. We are taken one tuning fork that should be excited and that should be kept over the tube, open end of the pipe. Then obviously what you have to say, the medium particles which are inside the pipe, they are going to be vibrate. The vibrating molecules can move from one place to the another place in the pipe. Then they should be moves like this. When that wave is touches the closed end, automatically the medium is closed. That's why here that should be again reflected back like this. This is the way how the stationary wave is formed in a closed pipe. Very simple children. We are taken one tuning fork that should be excited, and due to that one wave is generated that should be goes like this. It is the one progressive wave. And when it touches the bottom, obviously that is reflected because there is no further propagation is not possible. The wave is going to be stopped here only. Due to that should be comes like this and superimposed like this. Due to that, what you have to say, there is some superposition of two waves which are having same frequency and same amplitude. They are superimposed in opposite direction and they will forms the, what you have to say, stationary wave is formed. And next thing you have to remember here, that's very important children, what it is, in case of open pipe, at the open end there is some chance for further vibration of the particles. That's why always at the open end antinode will be formed. At this closed end there is no chance for further propagation of wave. That's why every time there is some here node is created. Clear? సో మనం ట్యూనింగ్ ఫోర్క్ తీసుకొని ఎగ్జైట్ చేసినప్పుడు ఒక వేవ్ అనేది జనరేట్ అవుతుంది, అది ఇక్కడికి వెళ్ళగానే రిఫ్లెక్ట్ అవుతుంది. సో ఏవైతే రెండు వేవ్స్ ఫామ్ అవుతుంది ఏర్పడి క్రియేట్ అయినాయో అవి రెండు సూపర్ ఇంపోజ్ అవ్వడం వల్ల మనకి ఒక స్టేషనరీ వేవ్ అనేది ఫామ్ అవుతుంది. స్టేషనరీ వేవ్ ఫామ్ అయినప్పుడు ఈ క్లోజ్డ్ పైప్లో మనం గుర్తుంచుకోవాల్సిన విషయం ఏంటంటే, ఎక్కడైతే ఓపెన్ ఎండ్ ఉంటుందో ఆ ఓపెన్ ఎండ్ దగ్గర వేవ్ అనేది ఫర్దర్గా వైబ్రేట్ అవ్వడానికి ఛాన్స్ ఉంటుంది కాబట్టి యాంటీనోడ్ అనేది ఫామ్ అవుతుంది. ఇక్కడ మాత్రం క్లోజ్డ్ ఎండ్ దగ్గర మాత్రం నోడ్ అనేది ఫామ్ అవుతుంది. సో దిస్ ఈజ్ ద వే హౌ ద స్టేషనరీ వేవ్ ఈస్ ఫార్మ్డ్ ఇన్ ఏ క్లోజ్డ్ పైప్. Clear? Now we want to define the harmonics and overtones. How we can get the expression for fundamental harmonic, third harmonic and fifth harmonic we will discuss here. Dear students, first we have to know about the fundamental harmonic or first harmonic. First thing is here, harmonic is nothing but frequencies. The minimum frequency required to form a stationary wave is called fundamental harmonic or ఫస్ట్ హార్మోనిక్. ఒక స్టేషనరీ వేవ్ ఫామ్ అవ్వాలంటే కావలసిన మినిమం ఫ్రీక్వెన్సీని మనం ఏమంటామంటే ఫండమెంటల్ హార్మోనిక్ ఆర్ ఫస్ట్ హార్మోనిక్ అని అంటాం. ఐ ఆల్రెడీ gave one definition for overtones. What is mean by overtones? The frequencies which are written as integral multiple of fundamental frequency. The frequencies are the harmonics which are integral multiple of fundamental harmonic, they are called overtones. ఏవైతే హార్మోనిక్స్ని మనం ఫండమెంటల్ ఫ్రీక్వెన్సీ యొక్క ఇంటిగ్రల్ మల్టిపుల్గా రాయగలుగుతామో వాటిని ఓవర్టోన్స్ అంటాము. అండ్ నౌ హియర్ ఫస్ట్ యూ హ్యావ్ టు నో అబౌట్ ది ఫండమెంటల్ హార్మోనిక్ ఎక్స్ప్రెషన్. హౌ వీ కెన్ డిరైవ్ ది ఫండమెంటల్ హార్మోనిక్ ఈక్వేషన్. సో లెట్స్ గో ఫర్ దట్. To form a fundamental harmonic, a stationary wave must be consist of one antinode and node. Look at the diagram. So when first harmonic will be formed, the stationary wave should be like this. Now the blue color is the pipe and red color it is what is? It is the stationary wave. It should be consist of what? Antinode and node. Clear? So to form the fundamental harmonic, stationary wave consists of one antinode and one node must be there. Clear? Then only we are getting the fundamental harmonic. And now here what you have to take, the length of the pipe is L. What it is? Length of the pipe is L. In this case what you have to write, length of the pipe should be equals to the, here it is antinode and this is the node. I already explained you the distance between antinode and node is, here it is lambda by 4. You have to remember that antinode ki node ki madhya distance lambda by 4. That's why length should be L should be equals to lambda by 4. Then what to write? L is equals to lambda by 4. From that what you have to write? Lambda is equals to 4L. Lambda is equals to 4L. Already we know that velocity of sound in air should be taken as what it is? V is equals to nu lambda. V is the velocity, nu is the frequency and lambda is the wavelength. From that what to write? Nu is equals to V by lambda. Nu is equals to V by lambda. For fundamental harmonic I am going to take that is nu 1. Nu 1 is equals to V by lambda. What is lambda value? 4L. Then V by 4L. Nu 1 is equals to V by 4L. That is the expression for fundamental harmonic or first harmonic in closed pipe. Nu 1 is equals to V by 4L. Now we have to derive the expression for third harmonic or first overtone, children. So to get the third harmonic, the stationary wave must be consist of two nodes and two antinodes. Look here, the stationary wave should be like this. In this, how many antinodes are there? This is the first antinode and this is the next antinode. Two antinodes are there and this is the first node and this is the second node. So to get the third harmonic, stationary wave must be consist of two nodes and two antinodes. That should be shown in the figure very clearly. So that should be consist of two nodes and two antinodes. In this case, you have to observe, in case of closed pipes, nodes and antinodes are equal in number. Number of antinodes should be equals to the number of nodes. స్టేషనరీ వేవ్లో మన స్టేషనరీ వేవ్ అనేది క్లోజ్డ్ పైప్లో ఫామ్ అవుతున్నప్పుడు మనకు ఖచ్చితంగా నెంబర్ ఆఫ్ యాంటీనోడ్స్ అనేవి నోడ్స్ ఈక్వల్గా ఉంటే అది మీరు విషయాన్ని గుర్తుపెట్టుకోండి. సో యాజ్ యువర్ సేమ్ ప్రాసెస్, వాట్ యూ హ్యావ్ టు సే, లెంత్ ఆఫ్ ది పైప్ ఈజ్ వాట్, దిస్ ఈజ్ వాట్, ఎల్. క్లియర్? అండ్ నౌ again same process, antinode to node, lambda by 4, again node to antinode, lambda by 4, and antinode to node, lambda by 4. That's why here the length of the pipe should be equals to the lambda by 4 plus lambda by 4 plus lambda by 4, 3 lambda by 4, lambda by 4 plus lambda by 4 plus lambda by 4. Then what you have to write, children? L is equals to 3 lambda by 4. So from that we can write, or lambda is equals to what we write, 4L by 3 we can write. Lambda is equals to 4L by 3 we will get, right? And as usual, what we know, the frequency formula is what? Nu is equals to V by lambda. Nu is equals to V by lambda, since V is equals to nu lambda formula. So in this case we are going to take nu is nu 3 and V by lambda. As usual, we have to substitute the lambda value. Then nu 3 is equals to what? V by 4L by 3, 4L by 3. Then what do we get? Nu 3 is equals to 3V by 4L. Nu 3 is equals to what? 3V by 4L. This is what we call third harmonic or first overtone, where nu 3 is what we call third harmonic or first overtone. What is first overtone? Because here we will write like this. What is nu 3 is equals to 3 into V by 4L, 3 into V by 4L. Then what do you write? Nu 3 is equals to 3 into V by 4L means what? Nu 1, fundamental harmonic. That's why nu 3 is equals to 3 into nu 1. That's why it is called third harmonic or first overtone. Children, in this way we will get the expression for third harmonic or first overtone. Clear? Now we have to derive the expression for fifth harmonic or second overtone. Fifth harmonic or second overtone. So to get the fifth harmonic, the stationary wave must be consist of 3 antinodes and 3 nodes as shown in figure. So మనకి ఫిఫ్త్ హార్మోనిక్ కావాలంటే ఖచ్చితంగా ఫిఫ్త్ హార్మోనిక్ సందర్భంలో స్టేషనరీ వేవ్కి ఖచ్చితంగా 1 యాంటీనోడ్, 2 సెకండ్, థర్డ్ వన్, 3 యాంటీనోడ్స్ ఫామ్ అవుతాయి అండ్ 3 నోడ్స్, 1 2 and this is 3. So in this way we are getting the stationary wave for fifth harmonic. As usual, then what you have to go for, length of the pipe should be equals to that particular wavelength. Then what you have to write here, L is equals to how many there? Lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4. That is what? Lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4 plus lambda by 4. How many there? L is equals to 5 lambda by 4. From that what you have to write? Lambda is equals to 4L by 5. What is lambda is equals to 4L by 5, children. So as usual, what we know, nu is equals to V by lambda. So frequency is equals to velocity by wavelength. Now we can write this is nu 5. What I'm going to take, nu is the nu 5, then V by lambda. Nu 5 is equals to what we have, lambda value V by 4L by 5. Then what you get, nu 5 is equals to 5V by 4L. So nu 5 is equals to 5V by 4L. From that what you have to write, children? Nu 5 is equals to 5 into V by 4L we can write. What we know, since nu 1 is equals to V by 4L, then substitute here nu 5 is equals to 5 into nu 1. That's why here children nu 5 is called what it is, fifth harmonic or second overtone. Clear children, you have to remember కాంపిటేటివ్ ఎగ్జామ్లో మనకి హార్మోనిక్స్ మీద చాలా ప్రాబ్లమ్స్ వస్తాయి, జాగ్రత్తగా గుర్తుపెట్టుకోండి. న్యూ 5 ఏమంటున్నాం, ఫిఫ్త్ హార్మోనిక్ ఆర్ సెకండ్ ఓవర్టోన్ చిల్డ్రన్. క్లియర్, దిస్ ఈస్ ద ఫార్మేషన్ ఆఫ్ ఫిఫ్త్ హార్మోనిక్ ఆర్ సెకండ్ ఓవర్టోన్ ఇన్ ఏ క్లోజ్. Friends, this is a very important, this point is very important for 2 marks, and in this question also 1 mark should be avoided for this. What it is, the ratio of harmonics and overtones. What is the ratio of harmonics and overtones in a closed pipe? So closed pipe లో వస్తున్నటువంటి హార్మోనిక్స్కి ఓవర్టోన్స్కి మధ్య రేషియో ఎంత ఉంటుంది అని అడుగుతాడు. సో ఆల్రెడీ వీ నో దట్ వాట్ ఇట్ ఈస్ హియర్, nu 1 is to nu 3 is to nu 5, that is equals to what we have. Nu 1 means what, v by 4l east and 3v by 4l, and next 5v by 4l. Nu 1 is v by 4l, nu 3 is 3v by 4l, nu 5 is 5 by 4l. So from that what you have to write children, that is equals to, so we cancel 4l, 4 cancel, what we get, 1 is to 3 is to 5. Therefore nu 1 is to nu 3 is to nu 5. So the ratio of harmonics in closed pipes is 1 is to 3 is to 5 children. So here you have to notice that in case of closed pipes only odd number of harmonics will be formed. Closed pipe లో ఆడ్ నెంబర్, బేస్ సంఖ్యలో ఉన్నటువంటి నెంబర్స్ మాత్రమే ఫామ్ అవుతాయి హార్మోనిక్స్. చూడండి 1 3 5, నెక్స్ట్ హార్మోనిక్ ఏమవుతుంది, 7th హార్మోనిక్ అవుతుంది. సో కాబట్టి 1 is to 3 is to 5 is to 7 we will write like that. So in closed pipe only odd number of harmonics found, but in case of open pipe both odd and even number of harmonics will be formed. Okay children, so this is about the formation of stationary waves in closed pipes. So ఈ వీడియో మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, కామెంట్ చేయండి. ఎవరికైనా మన ఛానల్కి అవసరం అనుకుంటే వాళ్ళకి సజెస్ట్ చేయండి. ఓకేనా, థ్యాంక్ యూ.